Assalamu alaikum, this is Saadat Nisar with the course on e-commerce. If you recall, we were discussing the concept IP addressing in the previous lecture. I told you that IP addresses are of 5 types: class A, B, C, D, and E type of IP addresses. Then I also familiarized you with the ranges. How do we calculate the minimum and maximum ranges in respect of class A, B, and C type of IP addresses? For public purposes, we are confronted with class A, B, and C type of addresses. D and E type are used for certain special purposes. I told you that in class A type, 1 byte is reserved to indicate the network address and the remaining 3 bytes are for the host machines on that network, which means that it gives rise to a very large network. There are 127 A-type networks possible, and there are about 16 million host machines which can be accommodated in class A-type network. How do we reach this figure? Just let me show you the concept. You have a slide before you on the screen. In the top row, you see there is a class A type IP address starting with 57, then 120, 40, 55. 57 indicates the class A network, and 120, 40, 55. These 3 numbers refer to a host machine on this type of network. For class A networks, 0 and 127, they are excluded, they are not put to any practical use. So we are left with 126 possible class A networks. Now, how do we reach the figure 16 million? I told you that there are 16 million host machines which can be accommodated at a maximum in class A type. Please notice that in the second byte, if I keep playing with the numbers, there are 2 raised to power 8, or in other words 256 different possibilities or combinations of zeros and ones which I can extract, which I can draw from this second byte, and at the same time I can fix or I can keep constant the numbers in byte number 3 and 4. So in other words, from byte number 2 alone, I can extract 2 raised to power 8 or 256 different host machine addresses. Similarly, if I keep the second byte number as constant and I play with the third byte number, from this third byte, I can also get 2 raised to power 8 or 256 different unique host machine addresses. On the same lines, if I keep the second byte and the third byte number as constant and I manipulate with the number in the fourth byte, again from this fourth byte I can also extract 2 raised to power 8 or 256 different combinations of zeros and ones. So in all, if we try to gather a concept, we can say that there are about 16 million host machines which can have unique addresses in class A type networks. Then we come to class B type. In class B, if you recall that there are 2 bytes reserved for the network address and the remaining 2 bytes are for the host machines on that network. It's a medium-sized network. According to a calculation, there are about 16,384 class B networks possible, and each having the capacity to accommodate about 65,000 host machines on it. How do we reach these figures? Let me explain the logic. You can notice that the range for class B is from 128 to 191. If we subtract 128 from 191, we get 64 different possibilities of zeros and 1 in the first byte alone. In other words, I can say that the first byte can generate 64 different options for me in terms of class B network addresses, whereas I keep the second byte as constant. I don't change 45, I keep 45 as constant in the second byte, and I keep playing with the first byte, and there are then 64 different possibilities which I can generate from just the first byte. Then if I keep the first byte in the class B address as constant, and I manipulate the second byte, there are then 2 raised to power 8 different possibilities, or 256 different possibilities. I can keep changing these numbers in the second byte, keeping the first byte number constant, and thereby I get a different class B network address. On the other hand, to get the host machine addresses, I have again 2 bytes. This is possible that I keep 29 in the third byte as constant, and I keep changing the numbers in the fourth byte, which give me 2 raised to power 8 or 256 different possibilities. Similarly, I can keep the fourth byte number constant, and I manipulate with the third byte number, which right now is 29. Again, the third byte can generate me 256 different possibilities. In all, if we visualize, then there are about 65,000 host machine addresses which I can generate in a class B network. Then we come to class C type networks. In class C, the first 3 bytes, they indicate the network address, and the fourth byte is reserved for indicating the host machine on that network. It's a very small type of network. There are 2 million class C networks possible, and there are 256 host machines which can be accommodated in each class C type of network. How do we reach the logic? Please recall that in class C there are 3 bytes for the network. Therefore, these are 3 bytes from which we can generate different class C network addresses. There are 2 raised to power 8 possibilities for class C networks which can be generated from the second byte if we keep the first byte number and the third byte number constant. Similarly, there are 2 raised to power 8 or 256 possibilities which can arise from the third byte, considering that we keep the first byte and second byte number constant. Similarly, we can also make use of the first byte to get a class C network. Remember, the range for class C networks is from 192 to 223. So if we subtract 192 from 223, there are 32 different possibilities. So in 32 different ways, we can change the number in the first byte to get a new class C network address while keeping the second and third byte numbers as the same. Again, then we can say that 2 million networks we can generate. Therefore, we have 2 million class C networks possible, and each has the capacity to accommodate up to 256 host machines on it. Then I want to introduce the concept subnet mask. An IP address is nothing without the accompanying subnet mask. A subnet mask is in the same format as the IP address. So you will find 4 decimal numbers which are separated by a dot, and we say that this is a subnet mask. What does a subnet mask do? A subnet mask, which always accompanies an IP address, it tells to the computer machines on the internet that this particular portion of the IP address relates to the network number or network address, and this portion of the IP address relates to the host machine on that network. Otherwise, you can visualize that this IP addressing scheme is for human beings, they have visualized, they have given this concept. How do we communicate this concept to the computer machines? Computers, they always view and understand information in terms of zeros and ones. So therefore, this provides the need to have a subnet mask which would elaborate, which would tell the computer machines on the internet that this particular portion is for the network and this for the host machine on that network. There are 3 default subnet masks available for class A, B and C types. For class A, the subnet mask is 255.0.0.0. For B, the default subnet mask is 255.255.0.0. And for C, the default subnet mask is 255 in the first byte, then in second byte again 255, in the third byte again 255, and in the fourth byte there is a 0. The logic behind these default subnet masks is that based upon the distinction of ones and zeros, then the computer machines on the internet like routers, etc., they understand that this information, this IP address part is for the network and this for the host machine. For example, in case of A type, since the default subnet mask starts with 255, that would tell to a router that the first byte, the first number in the IP address is for the network. So if there is the IP address 57.120.30.55 and the accompanying subnet mask is 255.0.0.0, accordingly the router would immediately understand that the number 57 in the IP address is for the network. I have to look for network number 57 where this particular host machine is residing. Similarly, in B type, in the first 2 bytes of the subnet mask, there are 255, which correspond to 8 ones in terms of binary in the 2 bytes, and the rest of the bytes, the third and fourth byte, these bytes contain zeros. So again, on the basis of distinction of ones and zeros, the router would understand that the first 2 numbers in the accompanying IP address, they refer to the network address, and the remaining 2 numbers in the IP address, they refer to the host machine on that network. Then I want to talk about very briefly about the concept subnetting. The subnetting techniques, they are based upon complicated mathematics. The concept is that at times we get a class C type address, we develop a class C network which can accommodate up to just 256 host machines, but then we internally divide the host part of the class C IP address in a way so that we have more flexibility, more range of accommodating different host machines on that class C network, and this would be done at an internal or organizational level. Further detail about this concept goes beyond the scope of this course, but you just need to have this notion that subnetting can be done. Certain ISPs, they get class C IP addresses, and then they become very cheap for the ISPs to buy, and thereafter they do the subnetting and they divide the host part further internally to get more range of host machines addresses for that network. IP addressing scheme, which envisages 32 bits, is likely to be replaced now by another version, that is IP version 6. We had this fear, the experts had this fear that probably after some time we might face the lack or the scarcity of IP addresses. So in order to gather more range of IP addresses, they have come up with this IP version 6, which is likely to replace the IP version 4 after a few years maybe. IP version 6, when implemented, would give 128-bit IP address. So instead of 32 bits, we have 128 bits for the addressing purposes. It would be in hexadecimal format, and like there would be digits from 0 to 9, and there would be characters from A to F. These digits from this range and the characters from this range, they would be combined, and they would then give rise to an IP address which would have 128 bits in terms of binary. It is believed that once this scheme, IP version 6, is implemented, it would give rise to about 3.4 into 10 raised to power 38 different unique IP addresses. In other words, your range for different IP addresses that gets exponentially enlarged. Our next major topic is domain name system. And this is the topic which we would be dealing with quite comprehensively in our today's lecture. What is a domain name? And why there should be a domain name? You may have noticed that human beings, they are quite uncomfortable while remembering numbers. So if we just confine ourselves to the IP addresses, the decimal numbers for accessing websites, for locating websites, it would be quite burdensome for human beings. That prompted the experts to develop a scheme that is called the domain name system. A domain name is defined as a user-friendly name. It is in the text format, which is easy to remember, and using which you can locate a website, you can access a website. For example, vu.edu, that is domain name. bestcomputers.com, another example of a domain name. The domain name system, I repeat, is defined as that strategy, that mechanism, that system which enables us to refer to computer machines on the internet in a friendly environment. Remember that domain names, they are unique. So therefore, it is not possible to have two vu.edu. Okay. Then, is it possible to have vu.edu and vu.org? The answer is yes. So in different top level domains, you can have the same second level domains, that is permissible. Similarly, it is valid that you have cs.vu.edu, and you can also have maths.vu.edu. There is no problem about this. As you can see in the slide before you, there is a domain name. We can also say a frequently qualified domain name or a simple domain name. This is www.cs.vu.edu, and through the domain name scheme, this domain name then gets translated or resolved into the corresponding IP address. You can see the IP address 129.167.69.47. What type of IP address it is? Can you tell me? Just look at the first byte, the first number, 129. You know the range for a class B is from 128 to 191. So therefore, just by looking at this first number, 129, you can immediately recognize that this is a class B type of network. Although this is a fictitious number, fictitious IP address, so it is not possible that you type www.cs.vu.edu and the corresponding IP would certainly be this. It's just an example. These domain names, they are assigned to you basically by the ISPs. So when you create your website, your web page, you take your content file to the ISPs, and then they host this website in their web server. They also then allocate a URL, your domain name, to you, using which the people can then access this particular web page. For this service, the ISPs would charge, of course, and you pay to the ISPs their fee, and then your domain name is then accordingly registered. In the slide before you, you can see the same URL, ecom.cs.vu.edu. This FQDN, or simply domain name, is translated into its corresponding IP address from right to left. In other words, it is processed from right to left. Each domain, as you can see, is separated by dots. EDU refers to the top level domain. Then comes VU. VU is, here you can see, it's the name of an organization, an academic institution. So your second level domains are normally the names of the organizations, the institutions, the companies whose domain name it is going to be. Then after second level domain, you can see the subdomains. In this particular example, CS is the subdomain. Subdomains are basically the geographical or functional or departmental units of the organization, of the company, of the business, etc. After the subdomain, you see the word ecom. Ecom here refers to the name of the web server machine. This is that web server machine which has got this particular content file stored in it, and when a request shall be made, this particular web page would be then supplied to the client machine. The domain name system, it basically works in a hierarchy. So as the slide before you shows, this hierarchy is viewed as a tree. At the top you see there is a node, and there are 7 branches which are being issued from this node. First branch edu, then gov, then net, then org, then com, then pk. And then you can see that the node edu has issued 2 further branches. One is vu and the other is pu in this particular example. Vu then becomes another node. It can generate 2 more branches. One is CS and the other is MS, or management science. And then the node CS is further split into 2 branches. One is ecom1 and the ecom2. You can understand that ecom1 here refers to a web server machine, and ecom2 also refers to a web server machine. So in this hierarchical fashion, in this node branch fashion, the domain names, they are designed and they become functional. Here I should point out to you the popular top level domains. Currently there are 7 popular top level domains which have been introduced. Very common TLD is .com, which relates to the commercial organizations. So whenever you are a commercial enterprise and you want your website to be registered, you are likely to be registered under the .com top level domain. Then .edu. Edu domain, top level domain, is for academic institutions. Then comes .org, where you are a non-commercial organization and you want to be registered online as a website, then .org would be the top level domain under which you can be got registered. Then comes .gov. .gov is that top level domain under which government agencies, their websites are registered. Afterwards, .net. ISPs, or those organizations which are related to the internet infrastructure, they are registered under .net. Then comes the .int top level domain. Certain international entities, organizations, they are registered under .int TLD. The country names consisting of 2 letters, they are also used as top level domains. So .pk, .uk, .ca, these are all top level domains which relate to the country name. They indicate the country. So these are some of the top level domains under which your websites are got registered. The domain name system mechanism hinges upon the working of domain name servers. A name server is a server machine on the internet which has got a specific task to perform. It has its hierarchical setup, which you will shortly be viewing how it works. A domain name server, in fact, has got a list, a database or a table contained in it, which maps the FQDN or domain name with the corresponding IP address. They play the fundamental role, therefore, in the translation of a domain name into its corresponding IP address. And there is a slide before you which shows this process of name translation or name resolution. We'll use the same example as I showed you earlier. Assuming that there is a client machine and it makes a request for a website, ecom.cs.vu.edu is the domain name or FQDN which the client machine enters. This request for this particular web page would first of all go to a local name server. This local name server would be provided by a local ISP whose client you are, who has given you the account. And then the local name server has got fed into it the IP addresses of all the root name servers or domain name servers. In other words, this local name server, by scheme, each ISP having its local name server would ensure that it contains the IP addresses of the top level domains. And so therefore, edu, .net, .com, .int, all these top level domains, their name servers' IP addresses would be already available in the local name server. Using this information, the local name server would then contact the root name server. In this particular example, edu is the root name server. So the name server which is at the top of the hierarchy, that is the root name server. This is the second step before you. The root name server then identifies this domain name and it discovers that it has no clue about ecom.cs.vu.edu. This information, the corresponding IP address against this domain name does not exist in its table, for that matter. Then it would contact the local name server and provide it the IP address of the name server which is directly below in hierarchy. You should understand that by scheme, each top level name server has got the IP address of the name server which is directly below it. This is the fundamental feature of this scheme, that each top level name server has got fed into it in its table the IP address of the name server below it. So therefore, the root name server would provide the IP address of the VU name server to the local name server. Using this information, then the local name server contacts the VU name server. VU name server again tries to find this information in its table, in its database, and it discovers that there is no ecom.cs.vu.edu against which there is any IP address listed. But again, by scheme, it has got the IP address of the name server which is below in hierarchy. Below in hierarchy, as you can see, is CS name server. So therefore, the VU name server provides the IP address of CS name server to the local name server. Using this information, then the local name server contacts the CS name server. CS name server consults its database and it finds that yes, there is an IP address of ecom available in its table or in its database. So ecom.cs.vu.edu, against it, the IP address of the web server ecom available with the CS name server in this example is 192.12.69.60. It is a fictitious IP address. This is the step number 7, and this information therefore is passed on to the local name server by the CS name server. From the local name server, then this information, this IP address which has now totally been translated, is provided to the client machine, and then client machine then using this IP address contacts the web server whose IP address has been received by the client machine, and then the request is made to the web server for that particular content page. Remember that on the client side, there is a special software which is inbuilt in the browser called Resolver. So initially, when a request is made by the client or a web page to the local name server, this request is transmitted through that Resolver, through that software program. So this is basically the process how the name resolution takes place on the internet, and a user-friendly domain name gets translated into the corresponding IP address. Remember, this IP address is that of a web server machine which has got contained in it the content files, and in this particular case, against ecom.cs.vu.edu, there would be a particular content file which you would earlier have designed and stored in this particular web server. So you may have noticed that in a similar number of steps, we are basically in a position to get the corresponding IP address which is got translated through the domain name that we had entered. This is how the domain name system works. There are a few concepts that I would like to discuss here with you. Let's go to the slide. As you can see on the slide before you, there is a URL http://vu.edu. The question is it an acceptable domain name? Yes, the answer is that it is acceptable, it is valid. We can say that this is a single zone domain name. It has got just one zone, vu.edu, and when the request would be made by local name server to the edu root name server, it would look at its table and then it would find that it has got the IP address of the web server vu. The vu is referring to the web server here, and the IP address of that web server would be then delivered to the local name server. Then in the following line, you see http://cs.vu.edu. It is an example of two-zone domain name. Again, the request would first go to the edu name server, which would pass on the IP address of the name server vu, and then vu name server, after looking in its database, would provide the IP address of the web server, which is recorded as CS web server in the database of the vu name server. Then in the following line, you see the URL http://ecom.cs.vu.edu. This is exactly the example I explained to you in the previous slide. It is possible to have more than 3 zones in a domain name. So if I write http://ecom.cs.vu.edu.pk, this is an example of a 4-zone domain name, and it would be processed in the similar fashion, in the similar way as we had discussed earlier. Then you may have noticed that at times we write URL like http://www.cs.vu.edu/folder/home.html. Here www refers to the default name of a web server, where you do not know the name of the web server, you can just put in www and it would substitute the actual name of the web server which you were not knowing. For the name resolution purposes, you should note that the portion in this particular URL, that is www.cs.vu.edu, only this particular portion would be required for translation purposes into IP address. So the further continuation of this URL into folder/home.html, that would not have any role for translation. Folder is the directory in which a content file in HTML called home.html is stored. Once you reach the default web server, then that web server would then dig out the home.html from its directory called folder. Otherwise, folder home.html, that would not have anything to do for the name translation purposes. Then a question may arise that can we have different IP addresses for different web content pages? The answer is yes. So in the previous example, this is possible that vu.edu is contained in a different web server having a different IP address, and cs.vu.edu is contained in a different web server. Similarly, ecom.cs.vu.edu can be a different web server having a different IP address. Also, we can store these three different web pages in the same web server having the same IP address. That would mean that with the help of the domain name system, when we write www.cs.vu.edu, we'll get an IP address. We'll get the same IP address of the web server when we write just cs.vu.edu, or we can also have the same IP address, same web server if we write simply vu.edu. That would mean that we have designed and we have registered our pages in such a way that they always give us the same IP address of the same web server. So in this way, we can have all these different content pages available in the same web server. So therefore, I can give you an analogy. These different web pages stored in a web server, they are just like residents living in a particular house. When we reach a house, then we can always make a request that we want to meet such and such person, and then accordingly that person can meet you. The question is, how do we identify that vu.edu is a different content file and cs.vu.edu is a different, and ecom.cs.vu.edu is a different content file, if all these three files are residing on the same web server having the same IP address? The answer is that when a web page request is made on the application layer header, these domain names, they are printed on that header. So based upon the difference in text, the distinction in text, then the server side is in a position to know that since vu.edu is a different text from cs.vu.edu, so therefore it has to provide a different web page. In other words, vu.edu, when this information reaches the web server through the application layer header, it would immediately understand that it corresponds, it is associated with a particular web file. And if the information is different, if it is rather cs.vu.edu, then since cs.vu.edu is different from just vu.edu, therefore the web server, on the basis of this distinction in text, would come to know that certainly then cs.vu.edu is a separate, a different content file residing with me, and I have to supply that file. Then the concept as to how can we get these domain names, what is the procedure for that purpose. When you develop your web content, when you develop your website, you take that website and you request at a local level to the ISP to provide you the web server where these content files, these web files, they can be resided. They charge the fee and then accordingly they give you a domain name under which your website is registered and hosted in the web server. Now, there is an organization called Internet Corporation for Assigned Names and Numbers. This is abbreviated as ICANN. So ICANN at a global level, ICANN basically an American-based company, American organization, whose jurisdiction is accepted by everyone worldwide. And this has got the jurisdiction, the power to administer and to regulate the task of registration of domain names worldwide. It ensures that there is no duplication of domain names when they are registered. At a global level, ICANN operates and there are certain sub-organizations that work under ICANN. And they have divided their tasks in different continents. These organizations which operate under ICANN are listed as, first of all, there is EPNIC, which is for Asia and Pacific Rim. Then comes ARIN. ARIN is responsible for America and South Africa. Then comes RIPE, NCC, which is for Europe, for former Soviet Union, and for North Africa. All these sub-organizations, they are further connected with the local ISPs. They have some contractual relationship with each other. So at a basic local level, we go to an ISP for the registration of our domain names. When we prepare our website, we host that website in the web server of the ISP and it gives us the domain name using which people can access our website. Then how do we get the IP addresses? We, being clients, we obtain our IP addresses from the ISPs. So if I am a client of an ISP, whenever I come on the internet for a session, the ISP would automatically assign me, allocate me an available IP address, and through that IP address, then my computer machine would be identified on the internet. The IP addresses, they can be static, they can be dynamic. Mostly for client machines, the IP addresses, they are dynamic. So they keep changing. Say if I come on the internet for a particular session, I might be assigned an IP address, and afterwards when I again log on to the internet, I may be given entirely a different IP address available with the ISP. ISPs, they have arranged a special server for the allocation of IP addresses that is called Dynamic Host Configuration Protocol server or DHCP server, which dynamically allocates the IP addresses to the client machines. The ISPs, how do they get the IP addresses? So whenever an ISP has a license to work as an ISP, it can contact with the ICANNs above mentioned sub-organizations and it can request for the IP addresses. It can say that I want to build a class B type of network. So if there is any available class B network, please allocate that class B network IP addresses to me. An ISP has to pay for that purpose to the ICANN and its sub-organizations, and then it is in a position to have those IP addresses, and further it can then assign those IP addresses to its clients as the need be. We are going to start another major topic today, which is networking devices. And under this heading, we shall examine as to what are bridges, switches, routers, how do they function, and how do they operate to enhance the bandwidth of a network. To start with, we'd first of all discuss the term network interface card and its specific function. On a LAN, on a network card is an essential component. A network card does two jobs for us. First of all, it converts the data inside a computer into serial data. I'll give you an example. Inside a computer, the data from the hard drive travels towards the processor in a parallel stream. So there can be more than one parallel streams of data, bit streams, which would be traveling from the hard drive to the processor inside the computer. However, in order to put this data on the connectivity media so that it can travel along the connectivity media to a receiving point, it is imperative, it is essential that this parallel data is converted first of all into a single line, a single lane. That is called serial transmission. NIC or network interface card inserted in a computer machine precisely does this job. It converts the parallel data into serial data so that it can travel along the connectivity media. On the receiving end, it does its job in a reverse. It again converts the serial data back to parallel data. That is it. The other important function that a network interface card has is that it has got printed on it an address, which is called Media Access Control Address or MAC address. This is a very important address. This is the hardware or the physical address which is residing inside a computer machine and which would ordinarily not change unless you remove the network interface card and place a new one in the computer. Your MAC address is going to remain the same. This Media Access Control Address or MAC address or hardware address, which is printed on the network interface card, it is in hexadecimal format. So as you can see in the slide before you, the MAC address consists of 12 hexadecimal characters, and these characters, they are picked up from the digit range 0 to 9 and from the character range A to F, and the combination of certain digits and letters, they constitute a MAC address. It can come in different formats. One shown in the slide before you is 090017A9B2EF. Another format of the same address is that it is colon separated. Then it can also come as hyphen separated. So at the bottom you see 09-00-17-A9-B2-EF. These are all the media access control or MAC addresses which would be available inside the computer machine printed on its network card. You should remember one thing, that at the back of these hexadecimal characters, 12 hexadecimal characters, there is in fact a pattern of 48 bits. So this gives us the clue, the information that there are 2 raised to power 48 unique MAC addresses possible. It is an unimaginably high number. You can even not calculate it. Therefore, it is possible that each time we have a unique MAC address on a network card. There is an organization called Institute of Electrical and Electronic Engineers, IEEE, America-based organization, which administers the task of allocation of MAC addresses. it acts as a supervisor, so it ensures that all those manufacturers who manufacture network cards, they should ensure that there is no duplication of a MAC address on the network card. That is the main job of IEEE as regards the allocation of MAC addresses. There is one more thing which I would like to point out here, and that is, on the internet, the cable modem uses an Ethernet card. So if you are going for a cable connection, you're going for a cable modem, then you will first of all have to install an Ethernet card, and on that Ethernet card which you are going to use on the internet, there would be printed this media access control or MAC address in the same format as you just saw. In case of, however, telephone modems, the MAC address is treated to be that address which is available on the modem adapter. In other words, the 12-digit address printed on the adapter of the telephone modem, that would be treated as the MAC address in case of telephone modems. So dear student, in our today's lecture, we have understood the concept of domain name system. We have understood that a domain name is translated into an IP address, and then with the help of that IP address, we can locate certain websites. Then we have also moved on to our next major topic, which is networking devices. And in that topic, we shall be discussing, inshallah, the working of bridges, switches, routers, and then the role of the ISPs. Till then, Allah Hafiz.